Hello everybody and welcome back to another visual pattern challenge. Today we've got soccer balls. Here is figure 1 of the pattern, here's figure 2, here's figure 3, and your challenge is to determine the number of soccer balls in figure 4. If you can do that, can you determine the number in figure 43? And could you write an equation that could be used to determine the number of soccer balls in any step at all? So that's the challenge. If you'd like to accept it, pause the video and see what you can do. All right, so I think the best way to approach this one, we've got the balls arranged in kind of an X, and the X's keep getting bigger. So, well, at least the arms get longer. So let's just see if we can find this one in this and see what got added. So we've got the ball in the middle, and then it looks like the arms are 3 long. So I'm going to just, draw those off. So that's figure 1 right there, and it looks like we've added 3 and 3 and 3 and 3. So it looks like we added 3 to each arm on that one. Now let's see if we can find this figure in the next one. So this would be the middle one, and then 3 and 3 more, and then 3 and 3 more, and then 3 and 3 more, and 3 and 3 more. And it looks like in figure 3, they also added 3 to each arm. So I'm going to guess for figure 4, we're going to have, 3 more balls added to each arm, like so. That's a lot of balls already. Let's count and see what we've got. So 3, 6, 9, 12 in each arm. So 12 times 4 arms would be 48, plus 1 in the middle would be 49. So I think there are 49 soccer balls in figure 4. All right, let's take a moment to analyze the numbers. Actually, before we do that, do you have a prediction? Can you tell what kind of pattern this is? Is it linear? Is it quadratic? Is it something else? Well, let's see what the numbers say, and we'll see if your guess is right. So I'll put the figure here and the number of balls. So in figure 1, we've got, let's see, that's 13. And in figure 2, that's going to be 25. And in figure 3, that's going to be 36, 37. And for figure 4, we are saying 49. So we analyze these numbers in a pattern by taking the difference between each step. So 25 minus 13 is 12, and 37 minus 25 is also 12, and 49 minus 37 is also 12. And this should make sense, right? Because we're adding in each step 3 balls in 4 places. 3 times 4 is 12. We're going up by 12 every time. So the difference between each step should be no surprise to you to be 12. Because this is a constant, the same number for each step, we know this is a linear pattern, and we can use the equation for a line, y equals mx plus b, to model that. And our m, the slope of the line, is going to be this rate of change from step to step. So we'll start with y equals 12x. And in that equation, x stands for the step number. And we don't know what the b is yet, but we can try it out with step 1 or figure 1 and see how close we are. So y should represent the total number of balls, and x is the figure number, so we're going to put 1 in for x. So to start with, we have y equals 12 times 1. Well, 12 times 1 is just 12, but we have 13 balls here. There's that 1 in the middle. So we just get to add it to make that come out. And that is our b. So our b is 1. So let's try this equation with the next step just to make sure we're not missing something here. So y equals 12 times step 2 plus 1. 12 times 2 would be 24 plus 1 is 25. That's how many we've got in step 2. And in step 3, y equals 12 times 3 plus 1. And 12 times 3 is 36, plus 1 is 37. Yep, looks like we're on the right track here. So I think we can be pretty sure that this equation, y equals 12x plus 1, is correct. And then to determine the number in figure 43, we just have to plug in 43 for x in this equation. So y equals 12 times 43 plus 1. Okay, what is 12 times 43? I think I'm going to do this in 2 steps. I'm going to think of this as 10 times 43 plus 2 times 43, right? Because 12 is 10 plus 2. So I can do that. And 10 times 43 is easy. That's 430. And 2 times 43 is 86. So that is 516. And then we still have our plus 1, so add that 1 there, and we're going to get 517 soccer balls in figure 43. Well, how'd that go for you? Did you get 49 for figure 4? Did you come up with this equation? Let me know. Thanks, everybody.